All right, welcome back to this live session. So you're welcome back once again to this live session. So as you can see, we are looking at financial mathematics. Okay, let me put it here. Basically, that's what we are looking at. As you can see on the screen, scrolling like that, that is what we are looking at for in today's video. So you're welcome back to this live session. So that is what you're going to look at for financial mathematics. Financial mathematics. So let me pull up my screen so that we'll get started very soon. Get started very soon. All right. All right, so we are starting right now. So let me share my screen. So we are good to go. All right, so you're welcome back once again to this live session. So as you can see, we are going through financial mathematics uh, as a concept that mostly we use in finance, a concept that we use in business decisions, a concept that we use in other areas in that light. So let's take note of that. So if you just join us, you're welcome back to this live session. So what is financial mathematics? So before we even get excited, we need to know the meaning of financial mathematics. Financial mathematics basically has to do with financial mathematics basically has to do with the use of financial models, okay? The use of financial models and financial mathematics or basic model to solve what financial problems. So for our decision making is concerned in relation to finance. Is that okay? So that is basically the idea about financial mathematics. We are talking about the use of what mathematics models. You are talking about the use of what math concept to deal with what financial problem. So far as decision on finance is concerned, so far as decision on finance is concerned, I hope that is clear. So that is the issue about what financial mathematics. That is the issue about financial mathematics. Most of the time, you can call it in other books. You can see this concept called as what financial engineering or financial or quantitative what finance. So once you heard of those, we mean what the same thing as what financial what mathematics. I hope that is clear. So that is what we need to understand when it comes to financial mathematics. That's what we need to understand when it comes to financial mathematics. So in this presentation, we'll be looking at certain key mathematics modules that can help us to actually deal with what financial problems so far as decision making is concerned and other issues in relation to other issues in relation towards finance. I hope that is clear. So we'll be starting with the concept on. So these are the things we're going to look at when it comes to the financial matter we're going to look at here. This is actually section one that you're going to look at in that light. So let's take note of that. So with this, we're going first of all going to look at the issue in relation to the issues in relation to the issues in relation to one arithmetic progression, arithmetic progression, arithmetic progression as one issue. Then we also be looking at the other brother called geometric what progression, geometric progression, and other mathematics model that help us to make what financial decisions and solve financial problems. So that is what we need to understand when it comes to the issue about what financial what math. So these are actually what we're going to look at. So first of all, start with the arithmetic progression as a key mathematics model to help us to solve financial problems, and move on to geometric progression. We're also going to talk about their applications. So the applications of the above two applications, and also going to talk about the issue about simple and compound what interest, compound interest, and others. And we look at a lot of key topics so far as mathematics and so far as financial mathematics is concerned. So right now, just going to look at the key mathematics model that help us to make financial decisions, that help us to solve what financial problems. So far as finances in our daily lives is concerned, right? So let's start with arithmetic progression. What is an arithmetic progression? So let's say, let's say numbers like, let's say I have numbers like, let's say one, let's say three, let's say five, let's say seven. You can clearly see that these numbers is being arranged based on a certain pattern. It's being arranged based on a certain pattern. What can you see here is that from when you start from one, you move on to what? Three. Is that okay? From three, you move on to what? Five. From five, move on to what? Seven. What can you draw about this what series? What can you draw about this pattern of what numbers being arranged? We can clearly see that from one to three, the difference in between is what? Two. Is that okay? And from three to five, in between is what? The same thing as two. Is that okay? And from five to seven, in between is what? Also what? Two. So at any time we have what? Numbers or items which are arranged in such a manner that from one item to another, there exists the same kind of what difference between from one item to another. We call such pattern of what arrangements as what arithmetic what progression. We call it arithmetic what progression. I hope that is clear. So most of the time in certain way you see like what we call AP. So one is here of AP. That's what we are talking. We're talking about arithmetic what progression. Arithmetic what progression. I hope that is clear. So that is the issue about arithmetic progression. So in doing that, there is a formula actually that we use to estimate what the arithmetic progression. Remember, as I said, these are mathematics models that help us to solve or make decisions in relation to our finances that we face day to day. Is that okay? And then also issues in relation to what finance problems and then decisions that we make on our finances on day-to-day what basis. I hope that is clear. So that's the issue about arithmetic progression. So at the end of the day, you're gonna have what a difference that will exist from one partner or from one item towards another. If it was to be numbers, fine. Or to be any other item, fine. So always we expect that the difference should what exist. So the first number here in arithmetic progression, we call it what? The first term. So most of the time we use A to represent that. We call it what? The first term. The first term. Is that okay? And then the difference that should be the same throughout this process or throughout this pattern, we call it what? The difference. So the two here we call what? The difference. So in other words, we see that what? D. Is that okay? And based on the pattern, if you have the last item existing, we call it what? The last term. The last term. We call that item what? The last term, based on the pattern that we have in that case. So that is the issue about arithmetic progression. So by formula, we can say that arithmetic progression, we can say that un, in terms of the number, it is always equal to your a, which is the first term, plus into brackets n minus 1. So the n represents what the number of terms we are talking about, and the d here represents what the difference that we want to understand. The a represents the first term. Is that okay? So that is the issue about arithmetical progression. So let's take an example. Let's take an example. Let's say we have, we are asked to, let's say, find what, let's say the seventh term of the sequence. We are asked to find the seventh term of the sequence. The seventh term of the sequence. 3, 7, and 11. So we asked, let's say, to find the seventh term of this sequence. 3, 7, and 11. How do you go by that? First of all, we can say that the first term, A, is going to be what? 3. And what is the difference from what? 3 to 7? What is the difference from 7 to what? 11? That should tell. So we can clearly see that from 3 to 7 is what? 4. And from 7 to 11 is what? 4. So we said with arithmetic progression or AP, always the difference should be the same from one item to another. I hope that is clear. So we can see that D is equal to what? 4. And then we are asked to what? Find the seventh. So the seventh term is going to be what? The n. So n is equal to what? 7. So therefore we can say that, therefore we can hopefully say that U7 is going to be 3 plus into brackets 7 minus 1 multiplying what? 4. I hope that is clear. So at this point, we can see that here is 3 plus into bracket. So here is going to give us what? 6 multiplying what? 4. I believe that is clear. All right. So at this point, we can say that here is 3, here 6 multiplying 4 is going to give us what? 24. And therefore we can say this equal to what? 27. So this becomes your U7. So the seventh term of this progression, or this what sequence in terms of pattern of arrangement from 3, 7, 11, the seventh term is what? 27, based on the AP formula. I hope that is clear. If you have any question, let me see in the comment section so I will know how to respond. So that is the concept about what? Arithmetic progression, or mostly in other books you can see that's called as AP as a shortcut form of this concept. I hope that is clear. So let's try another example so that we are good to go in that case. So let's say we are also asked to find, let's say, the 10th term of the sequence. The 10th term of the sequence. Let's say you have this sequence 2, 7, and 12. So you're asked to find what? The 10th term of this sequence. So how do you do that? We can say that here n is going to be 10, right? N is going to be 10. Then our a is going to be 2. And then the difference is going to be from the comparison of what the first term as against the second term, which is going to give us what? Likely going to give us 5. So we can say that difference is equal to what? 5. So therefore we can say that here the 10th term, which is what? U10, is going to give us 10 plus into brackets 10 minus 1, or multiplying the difference of what? 5. Is that okay? So here we can see that here is 10 plus 1 minus 10 is going to give us what? 9 multiplying 5. So we can hopefully say that here is 10 plus 45, and therefore here is going to give us what? 55. So that becomes what? The 10th term of this sequence, 2, 7, and what? 12. I believe that is clear. So that's the issue about the sequence. But then at times you may also be interested to find the sum of a particular term. Now here we are talking about the individual terms you want to locate within what a pattern. But at times you may ask to find what the sum of what a particular term. Is that okay? From, let's say, the first to what, that particular number. So we are asked to find the sum. How do you go by that? In finding the sum of what an arithmetic progression, we have what two formulas. We have to follow it and go. We can go by first, we call it xn. You can go by the first one, which is what n over 2, or into bracket twice of a plus into bracket n minus 1, or multiplying d. This is the first formula you can use when it comes to what, find the sum of what a particular what progression with regards to arithmetic what progression. I believe that is clear. Right. So that is the first formula. We can also use this formula too. That sum of what a particular term, it can also be n over 2 into bracket L plus what D. We also have this formula there if you want to find what the sum of what to the sum of what a particular what term. Sorry, the sum of a particular what term. So we use the second formula where we know the last term of what a particular progression. Is that okay? And use the first formula where actually you want to find the sum of any particular what number. Is that okay? So most of the times to help you to move faster, we use the second formula if you want to find the the sum given the last term in the sequence, giving the last term in the sequence, and then you are good to go. I hope the formula is right for the second formula. If that is true, then fine. So that is how the whole issue go about when it comes to find a sum. So let's take an example. We have, let's say we have, let's say we have patterns like, let's say we start from 5 to, let's say, 5, 9, 5, 9, then you move on to 13, then you move on to, let's say, 17, and you're asked to, let's say, find the sum of, let's say, the 10th term. You're asked to find this, let's say, the sum of the 10th term out of this progression. How do you go by that? How do you go by that? To do that, so that we know that sum, so that's going to present as what? Sn, who is going to be what? 10, right? So here our n is 10, and we can say that our a is going to give us what? 5. Is that okay? And then the difference from 5 to 9 is going to give us what? 4. Likewise, from 9 to what? 13 is going to give us the same thing as 4. So therefore, we can say that D is going to give us 4. Is that okay? So straight away, we can say that X10 is going to give us what? 10 over 2 based on the first formula. Is that okay? Multiplying twice. And we know A is what? 5, right? So A is 5 plus into bracket N, that is 10 minus 1, all multiplied by what? 4. That's the first formula. Is that okay? So at this point, we can say that here is going to give me 5. And with your calculation, you perform the bracket operations first. Is that okay? So here is going to give me 10. And here is going to give me, so 10 minus 1 is going to give me what? 9. 9 multiplying 4 going to fetch me something like what? Is it 36? 9, 4. Is it 36? Okay, if that is true, then that is cool. All right. So at this point, you can say that 10 multiply 10 plus 36 is going to give us what? 46. Is that okay? So 5 multiplying 46. The final answer you're going to get should be the right answer. So multiply this for me. Let me see in the comment section. The answer you're going to get for 5 multiplying 46. So that is what we need to understand when it comes to the arithmetic progression. I hope that is clear. I hope that is clear in terms of what the term and then the sum. terms of the term and then the sum. So that is the issue about arithmetic or progression. So if you have any question, let me see in the comments. If you just join us, you're welcome back to this live session. So today, actually, we are going through financial mathematics and we are starting from the arithmetic progression. That's where we are starting. We have talk, spoke about a lot of issues as far as financial mathematics and arithmetic progression is also what concerned. I hope that is clear. So that is the issue about arithmetic progression. So let's move on to geometric what progression. So geometric progression to we also want to find what the same as the particular term and then the sum of the term. Actually, that's what we are looking at as so far as financial mathematics is concerned in that case. So let's take note of that. So let's move on to talk about so here, provide me an answer. This one providing me an answer so that I write it there. Let me see in the comment section so that I will know how to see the whether that's right or wrong. All right, so let's move on to geometrical progression. Let's move on to geometric progression. Let's move on to geometric progression. Let's move on to geometric progression. Is that okay? All right. So when it comes to geometric progression, please, if you're online, make sure to share this video out to your friends. Please share this video out, share his videos out so that your friends can join us so that we are good to go. Is that okay? So please make sure to share this video out so that others can join so that we all watch in that case. Okay. So let's see. Okay, I see some comment here. Abuaje Da Costa saying that let's see. It says what? Okay, saying oh is what 230. Okay, if that's all good, if that's what you had, that's fine. No problem with that. Okay, that's good. Thanks. So please share this video out so that your friends can join us, knowing that we are live, so that you also learn in that case. So let's share this video out so that others can join in that case. So let's move on to geometric progression. Let's move on to geometric progression. So geometric progression to actually is also actually about a pattern of what numbers, a pattern of items that have been arranged. Is that okay? Is that okay? That's how it's been arranged. So as we dealt with the arithmetic progression, geometric progression is actually the opposite where we are talking about what difference geometric progression instead of here when it comes to arithmetic progression where we say that to find what the difference is always the u2 compare with what u1 that you take the first term taken from the second term. When it comes to arithmetic progression, so when it comes to geometric progression, we represent the d, the difference, as what r. We call it what common ratio. And to find the common ratio, it is always what the u2 over what u1. That's for example, okay, or let's say u3 over what u2. So that is the issue about geometric progression. Instead of here subtracting the first term from the second term, here we find the quotient of what the second term as against what the first term, or the third term as against what the second term. So that is the issue about our geometric progression. And then the issue about the first term remains the same. The end given the particular question doesn't remain the same, and other issues in relation to that. So when it comes to the geometric progression to actually also have what a formula that we use to estimate the sum, we use to estimate or find the particular what term that we want to talk about in relation to a particular series or pattern within the within the pattern or within the item that has been arranged. Is that okay? So let's look at the formula. Most of the time, you also call this word as GP or exponential what sequence. Either you see geometric progression or exponential sequence, it's the same thing as that. So let's take note of that. Let's take note of that. Let's take note of that. So with this, for you to find a particular term, here's a formula for finding a particular term. Most of the time you use what UN. So to find a particular term, let's say UN, it is always going to be your A, that's the first term, multiplying what your common ratio and raised to the power n minus what 1. Remember, the n as a power is on top of what the r. Is that okay? So that's actually the formula we use to find what the geometrical progression. If you want to find a particular term within the pattern or within the ideas in the range, that is the formula that we use. I hope that is clear. All right, so having gotten the formula, let's see, let's take an example. Let's say we are asked to find the fourth term of the sequence. You're asked to find the fourth term of the sequence. Let's say this is a sequence. So I have my sequence 2, I have my sequence 2, I have here to be 6, and I have here to be, let's say, 18. And you're asked to find what? The fourth term of this sequence. You're asked to find the fourth term of this sequence. Fourth term of this sequence. How do you go by that? So to find the fourth term of this sequence is very simple, okay? So here we can say that n is equal to what? 4. Accepted. Is that okay? We're gonna say that a is equal to what? 2. Accepted. We can conclude by saying that r is equal to, which is what? 6 over 2, which is the same thing as what? 18 over what? 6. I hope that is accepted. So in that light, we can say that r is equal to 3. Is that okay? Because 6 divided by 2 is 3. 18 divided by 6 is what? 3. So when it comes to the geometric progression 2, the common ratios are the same irrespective of the arrangement. So when you divide whatever term you divide by the term that comes before that term, you get the same what answer. So that is actually a geometric what progression or exponential what sequence. I hope that is correct. So in that light, if I'm asked to find the fourth term of this sequence, which is what 2, 6, and 18, is going to be, so with your formula, we can say that therefore U4 is going to give us the first term, which was what 2, multiplying common ratio, which is what 3, and then to the power of what 4 minus what 1. So therefore we can say that U4 is going to give me what, so you're going to give me 2 into bracket, so you're going to give me 3 into to the power of what 3, or 4 minus 1 going to give me 3, right? So therefore we can say that U4 is going to give me 3 to the power of 3 is going to give me what 27. Is that okay? So I can say that here is what 54, and that's going to be the term for U4 in this what sequence. So for you to find what U4 is actually what 54. So 54 is the fourth term. 54 is the fourth term of this sequence. So let's take note of that. Let's take note of that. Let's take note of that. So that is the issue in relation to geometric what progression. So having gotten to know how to find a particular term within a particular sequence, how do you also go to find the sum of what that particular term? How do you then find the sum of that particular term? So when you want to find the sum, actually it also come with what two formulas. It also come with two formulas. In a case, we use these two formulas where we have r, where r is less than 1, or we have r greater than what 1. These are the issues that we deal with when it comes to these formulas. So when it comes to the sum, two formulas that we use to estimate the sum come into play where we have this condition existing, where we have the common ratio to be greater than 1 or the common ratio to be less than 1. And each of them will denote which kind of the sum formula you should use at the end of the day. So let's take note of that. So in doing that, we have a formula that we use to estimate what the sum of these what expressions. So let's see how we go by that. Let's see how we go by that. So the first formula, this is how the first formula is being estimated. This is how the first formula is being estimated when it comes to the sum. So when it comes to the sum of our geometric progression, okay, when it comes to the sum of geometric progression, we said that xn, when I want to see the xn means the sum of that particular term is always going to give you your first term multiplying 1 minus what r to the power of what n. Is that okay? Or divided by 1 minus r. So remember here r is not equal to what? R is not equal to what? 1. So take note of that here. R is not equal to what? 1. But if R is equal to 1, then you're gonna make the whole expression what undefined. That's why you're saying that R is not equal to what? 1. So we use this formula where we have r to be what less than 1. We can also use this. You can also have this formula also represented the sum. If you have, let's say, xn to be equal to a, actually it's the same thing, but just look at the difference between the two. You can denote that this is the reason why we use this when it comes to this situation. So we can say that here a into brackets r to the power of n minus 1 all over r minus what 1. Is that okay? Here in the case where r is greater than what 1. So if r is greater than 1, then we go by what the second what formula. We go by the second what formula. We go by the second formula. So let's take note of that. Let's take note of that. These are very, very important when it comes to financial mathematics, when it comes to making financial decisions, when it comes to solving financial problems. These models will help you to actually make decisions as to how to go about that in that case. So let's take note of that. At this point, you have any question? Let me see in the comments section so that I know how to respond to that in that case. If there is any question, let me see in the comment section. So these are actually the formula that we use to estimate the sum of what geometric progression. So let's take an example to clarify this. After that, we move on to the applications of what this concept that we have learned. The application will help us to understand much more better in that case. So let's take this example. Find the sum of the first. You're asked to find the sum of the first what five terms of. So here you're asked to find the sum of the first five terms. In this case, so these are the sequence for this. So you have what 1/2. Is that okay? We have 3/4, and we have 9/8, and we have our three dots. So this is how we ask to find what the sum of the first what five terms. So here we can say that our n is equal to what 5, right? And for us to find our common ratio is going to be 3 out of 4 divided by 1 out of 2. Is that okay? Which is the same thing as 9 out of 8 divided by 3 out of what 4. I believe that is clear. So at this point, with the help of the calculator, let's see. So I can see that here it's going to give me 3 out of 4 multiplying the reciprocal of what the denominator, which is what 2 out of 1. So then I can say that here I'm gonna have here to be what 6 out of 4. It's going to give me what? It's going to give me here 2 goes to 6 how many times? 3, 2 goes to 4 how many times? Which is what 2. So I can say that here is going to give me 3/2. It's the same thing as the second one, which is 9/8 divided by 3. Let's see for that one. So here, 9/8 multiplying the reciprocal of 4 over what? 3. So 3 goes to self 1, 3 goes here 3. 4 goes here 1, 4 goes here what 2. So the same thing as what that. So you're going to get what 3/2. So we can say that our common ratio is equal to 3/2. So once you're able to find your common ratio to be what 3/2, then you can go on to apply your formula. So in this case, we can see that r is greater than what 1, right? So we are going to use what the second formula, which is what a into bracket r to the power of n minus 1 all over r minus 1. I hope that is clear. So here we can show that we say that therefore the sum of what the first five terms is going to give us. I know my a in the sequence was what 1/2. So it's going to give me 1/2 into bracket. I know my r is what 3/2, and to the power of what n, which is what 5. Is that okay? Minus. So we are using the second formula because r is greater than what 1. So minus 1. Is that okay? And then divided by 3/2 minus what 1. And then divided by 3/2 minus 1. I hope that is clear at this stage. So with the help of your calculator, you should be able to arrive at a particular answer for this. So let's see what we're going to get for this. I leave it to you. Provide an answer for me. Let's see in the comment section. Is that okay? I don't have my calculator right now here, but I'll get it. Right, don't worry. So that is that you need to understand. Is that okay? So that is the issue about what the sum of what arithmetic progression. So here, what do you get when you use your calculator? 1/2 into bracket 3/2 to the power of 5 minus 1 all over 3/2 minus 1. What do you get for this? Let's see what you get, and let me see in the comment section. So I'll respond to it in that case. So that is the issue when it comes to the sum of what arithmetic progression. So if r is less than 1, then you apply the first what formula. But then if r is greater than 1, you apply what the second formula, and then you are good to go in that case. So let's take note of that. Let's take note of that. So here, provide an answer for me so that I have that one represented in that. Let me see in the comment section in that light. So having gotten the basic ideas about arithmetic progression and geometric progression, let's show that we move on to the applications of what these principles that we just learned. Is that okay? So let's talk about applications of what these two principles. So application, we'll talk about application. So application actually, when you're talking about application of what something, we are talking about how that concept can help deal with what a situation that we find ourselves what in. So here application, another application side, you'll be given a scenario and we expect you to apply your basic understanding in the concept that you've learned so that you can easily solve question in relation to the applications. I hope that is clear. So that is the issue when it comes to the application. So with the application, always you like to ensure that you read the question and you understand the key issues that they want to bring it out, and then apply the basic math models that you have learned to solve those issues. So let's take note of that. Let's keep sharing out this video so that others can join. So at this point, you have any question for me? Let me see in the comment section so I will know how to respond to it in that case. Respond to it in that case. Respond to it in that case. All right, so let's take an example with this application. We're just taking an example with this so that we are good to go. Let's take an example here. So we have Yao, who is a manufacturer. Is that okay? So let me write so that we are good to go. So let me write here so that we are good to go. So this is how it goes. Yao, a manufacturer. Yao, a manufacturer produces 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 1,200 computers. Computers, is that okay? Computers each week produces what? 1,200 computers each week. Is that okay? After 1 week, full stop. After 1 week, after oh sorry, after week one, it should be week one. So after week one, he increases, he increases, he increases production, he increases production by increase production by. So with the production, we have what the scales for the production. We have the first scheme and you have the second one scheme. So with the first scheme, we have production increase to what 8 computers each week. So scheme one, or let's say scale or any scheme can be the same thing. So scheme one, it was what 80 computers, 80 computers. Sorry for the handwriting each week. And then that of scheme two, that's scheme two. That of scheme two, 5% each week. So here can give you actual quantity, can give you what percentage. So 5%, 5% each week, each week. So the question here is A, find the output in week 20 under each scheme. Find the output in week 20 under each scheme. Find the output, find the output in week 20 under each scheme. Under each scheme. So let's deal with the first one and move on to the second question that we have. So here is a case that we have Yao, who is a manufacturer who produces what 1,200 computers each 1,200 computers what each week. Let me add a week here. There's a week for here. So each week, is that okay? And the question you want to tell us that after 1 week, after week one, yes, after week one, he increases production by what? So with the production increase, it has been divided into what various sections. So you have scheme one, which is what 80 computers each week, and we have what scheme two, which is what 5% of each week. So the question is telling us that we should find the output in week 20 under each what scheme, under each scheme. So how do you go by this? It's very simple. So you can clearly see that Yahoo produces what 1,200 computers each week. So each week, what are they saying here? So you can see that the first week he produces what 1,200. So that 1,200 going to be what your A. That's your first what term. Is that okay? Your first term. And as and when you produce it, realize that you're saying that in the question, you tell us that he increased the production by what 80 computers for the first scheme. So the 80 they can be what the difference. Is that okay? The 80 is going to be, or let's see, so that I don't make any mistake. Yes, so the 8 is going to be what? The difference in this case. The 8 is going to be the difference in this case. Is that okay? But the increase means that each week he increased his production by what? 80 what computers. Is that okay? So that's going to be what? The difference. That's going to be the difference. And we are asked to find what? The output in week 20. So the week 20 is going to be what? The number. The number you want to find. So in week 20, what will be the output of computers that a manufacturer would have produced within that week 20? So very simple. We can say that our first term, since we know our first term to be equal to 1,200 computers, and we know the difference to be equal to what 80, and we also know the number of weeks that is produced. In this case, the question gave us was what 20. We can easily find what. So here is actually it's actually what arithmetic what progression. So that is D. So we can say that therefore U20 gonna give us what 1,200 plus into bracket n is what 20. Sorry, n is 20 minus 1. Is that okay? And then multiply by D, which is what 80. So at this point we can say that here is 1,200 plus, and we know 1 minus 20 gonna give us what 19. So I can say that here is what 80 into bracket what 19. So here with the help of a calculator, we should be able to arrive at a total of what 2,700 and what 20. You can confirm for me to see if that is right. 2,700 and what 20. 2,720. That's what we're going to get for the first scheme, which is what where you have what 80. But for you to deal with the second scheme, since we are given in percentage, we're going to apply 5% on the 1,200 as what the first production output that Yahoo produces. Is that okay? So you're going to apply that on it, and then you are good to go in that case. So let's see for that one. Let's see for that one too, so that we are good to go in that case. All right, so I'm coming. So we continue. All right, thank you for waiting. I'll just to key in my plug in my laptop. So it's actually going off, so that I need to do that. Then I'm good to go. So with the second scheme, as I was saying, remember when it comes to percentages, geometric progression is actually the best skill or the best mathematical model that can help us what deal with percentages. So in this case, the 5% here that we have each week, we're going to apply what our geometric what progression. But geometric progression deals with what percentages. Is that okay? So let's take note of that. So in this case, we can say that here's what we need to do to find out the common ratio for this. So we can say that the common ratio R is going to be, since each week it increased by what 5%, we assume that we start from 0, then move on to 5, and move on to in that manner. So the how do you find the common ratio? So to find the common ratio is going to be the increase that you're going to add to 100% and then divided by what? 100. Is that okay? So the idea is that fine, if you have the percentage in terms of the increase to be 5%, that is the goal. So for you to find what, let's say from 1, or let's say from 0, you move on to, let's say, 5. Is that okay? And then on and on to, let's say, get here to, well, let's say 100%. And let's say from 100%, because since the difference going to percentage difference going to what? 5%, you move on to what? 105. So here to find actual the common ratio for this is actually going to give you what? Or let's say, let me add up some to it, 110. Straight away, common ratio going to, so if I should take what? The 100 over here, actually, because the 5% is actually the increase of the computers that you produce, I can see that common ratio, I can use what? I'll add 5% to 100 and then divide by what? 100, and I'm good to go. So I can say that R is going to give me what? 1.005 as my common ratio. So once I'm able to find my common ratio, therefore I can say that U20 and the second scheme is going to give me what? I know my A is what? 1200, and then multiply by my R, which is what? 1.05. Is that okay? To the power of what? 20 minus what? 1. And here, with the help of your calculator, with the help of your calculator, you should be able to arrive at, you should be able to arrive at what? 303, 303, 3032, sorry, point 34. Is that okay? 0.34. So if you want to have the approximation, you can see that here is 3032 approximated, and you are good to go. So let's take note of that. Let's take note of